First things first, I don't want to assume any knowledge, so let me give you a little bit of background of what I'm going to be talking about. When I say operations, security, company culture, technical debt, and you, I had someone ask me earlier, like, what operations are. And that's like a perfectly valid question. For some reason, I was like, well, everybody knows what operations are, right? Operations is, take a company like Facebook. You're an end user. Facebook serves traffic on their web server, and developers develop the software. The operators are usually the people that take the software that the developers write, and they make it run in a scalable, secure, and hopefully efficient manner. In a nutshell, that's what it is. Like, so no service interruption, scalable, so it can go from 10 requests to millions of requests, protect against hackers. There's a lot to the job, but when I mention operations, that's mostly what I'm talking about, is the folks that take software and make it run so that you can consume it. Yes?
So the operations are just DevOps engineers?
Yeah, basically. I mean, I'm going to go over a little bit of I wouldn't say history, but there's a change in the way things are done now that is pretty significant. DevOps is kind of a newer-ish concept, whereas like IT's been run a certain way for the past 20 years, and now things are shifting very quickly. So I was going to try to get into that. Yeah, yeah. When I talk about security, I'm talking about not just hackers and hoodies grabbing your goodies. I'm talking about the security of your systems, in that, like, the data has integrity. You know that when you make a query, you're going to get data back. That's part of security. Company culture is kind of a bit of a fuzzy term. I was going to get into in a little bit, but basically, you take what you read in the news about, say, Facebook's company culture or Uber's company culture. Even my own company culture. Like I think we do things really well. I work for Barracuda, by the way. That they all have different reps and different feels to them, and if you guys get hired with one of these bigger companies, you really have to think about what company culture is and how important it is to you. It's important to a lot of people. It certainly is to me. So technical debt is when I want to get it done now, or I want to get it done right. Sometimes you have to get it done now. Technical debt is how much you stack that I want to get it done now versus right, without having to go back and like clean up your stuff. So it's a huge thing with a lot of companies, because as you stack that, those special cases one on top of another, what you get is a very inefficient system, and it can cause a lot of drag on culture and your efficiency at your job, and how much toil you have. So it's pretty important. So I'm not going to get terribly technical. If you came for like super technical stuff, this isn't it. So like if you want to split, totally understand, but I hope you stick around. Let's see. Okay, so things I'm going to be covering. I'm going to cover the basics, things that I think are basic to my day in and day out. And then we're going to get into kind of next level tasks. Not all companies are there where they can implement some of these things from a site reliability engineering standpoint, but they're important to like be aware of. And then we can hopefully get some Q&A. And where am I at? I'm at 16 minutes. Wow, I didn't expect to take that long on that first slide. All right, so we'll skip that. Who am I? I'm currently working at Barracuda Networks. I've been doing tech for about 20 years, a little less than 20 years. I am a bit of a security wonk. I love security. I've been going to Black Hat or DEF CON for 15 years. I love to compete, so I've won 3 black badges at DEF CON as a team member, not individually. I've developed a lot of systems and software. I worked for the city for 10 years, so if you open up your tap, likely I touched the systems that you use for that. And I've written a lot of software for my company that I'm at right now. I'm terrible at front end too, by the way, so I'm going to mention a site a little later. If you look at the front end and you're like, that's garbage, well, yeah, I know. So maybe you can help me improve it. I'm probably what a lot of people would consider a graybeard, Linux graybeard. This is Ken Thompson and Dennis Ritchie, by the way. They invented the C programming language. Lots of brain power in that picture. Let's see. So I'm not assuming that everybody's going to know what I'm talking about. So or I'm not going to assume any knowledge. So when I go over these basics and you're like, yeah, I know, just bear with me. These are all things that are important, kind of fundamental to, in my opinion, to a tech's day in and day out. First, I'll start with software development. I love software development. I read programming books when I go to bed, so it helps me go to sleep, and I learn something in the process. So, first and foremost, use source control. How many of you are unfamiliar with? Well, I should say, how many are familiar with Git? Use Git on a regular basis. Okay, cool. So you guys know how important it is, and it's a complex tool, and it's good to get to know. Host your code somewhere other than your computer, because Git by itself isn't a panacea, and make sure that you push your commits. I lost 2 weeks of work recently, like, I don't know, 6 months ago, where I forgot to push my commits and I lost my locals. And yeah, you make that mistake once. And Git reflog, which is like kind of a hack to get back your history, didn't work for me, unfortunately. So. Back up your stuff. So hard drives do 3 things. They read, they write, and they die. Like, that's all you need to know about storage. So you will lose things if you don't do this. And unfortunately, I've been in touch with people that have suffered catastrophic data failure, and it's not fun. Do something about it before it bites you. Always have your parachute, and backups that are untested might as well not exist. So make sure that your backups exist, and that you at least do some restores on a regular basis to make sure that they function okay. Redundancy is not disaster recovery. This one takes special circumstances to get bit by, but you always have a redundant database that's spanning 3 data centers, right? You have one in the East Coast and one on the West Coast and one in Europe, and you're like, my data's like redundant, like, I could suffer disaster, like one data center could go down and I'm fine. Yeah, but what if Joe deletes all the tables? Like, what happens then? Right? Then redundancy becomes a liability. Then everything gets screwed up. So you still need to back up your enterprise grade data. It's really important. I can't stress this enough, but sometimes you have to go through that hard lesson at least once in order for it to sink in. So hopefully you don't. If you're working on production, if you're working on services that people consume, that has a customer base, have a dev and production environment separate, and have them mimic and mirror each other. Staging is another type of environment. It may not necessarily be completely required, but it's good to have. But development, production, you want to have an environment in development that you can break stuff, that you have no hesitancy to run a command and be like, oh, I broke it, oh well, and then you revert. Rinse and repeat. You can move quicker, you can move with more confidence. Once you test it in development, you can move it into staging where maybe you have 5% of your customer traffic going to it. So make sure that it takes some load and it doesn't completely break, and then move your code over to production where you deploy it Even when you test in development, you test in staging, your code changes can break things in production, and I tell you why. When you have millions of records or millions of hits happening, software behaves differently. It's just the way it is. So don't assume that things are going to work if they work in both of those environments. You deploy it at production, and you're like, oh, I'm getting, I just tested something recently where I was getting, 100,000 hits a second, and my software completely, fell down, and I had to account for lower level system changes, open sockets, and a whole bunch of other stuff that you normally don't run into on day to day, things you never think about. When you're developing software, it's important to have short iteration cycles. Now they call it agile. They have a name for it now. I think it's just a short iteration cycle where you do initial planning. You go through your planning requirements, you deploy, rinse and repeat, just kind of, you make a change, you deploy to your dev and staging, test, then deploy to production. The way it was done previously was that people would have these monolithic releases that would go 6 months in between, and then everything would just, like you would have this big crunch at the company and everything would break and everybody would stressed out. And, this is a much more efficient and quote unquote, like as the name suggests, agile way of doing things where you're constantly pushing to production. And if something breaks, you revert it. You go back. Get feedback from your users. Get feedback via metrics. If something takes seconds to load, people don't want to use your site. So if you make this really awesome change and it does cool things, but it adds a second latency to your response times, people aren't going to use it. You're actually going to piss them off. So keep that in mind. Shiny new features are useless if your user experience sucks. Think small. Excuse me. It's easy to get stuck in the trap where you have this idea of the way something's going to work, and you start building this huge application with all these tangled dependencies. At some point, you need to step back and go, well, I need to make this smaller. I need to break out the components so that we don't have so many dependencies. And this is called microservices architecture. And from these little things, you can really build out large systems that tend to scale much better if you make things kind of very specific. So this service retrieves this data from this database, and then you have a database that serves that service. You have the same thing over here. Service B, database B. Service C, database C. So I can do maintenance and code updates and iteration on one service without breaking everything else. It's really important. And things like containers and lambdas and, a lot of cloud services make it really easy. So I'm going to give you an example of a user interface here. This is the site that I said like the UI sucks, but I made it for a very specific purpose to test egress firewall rules. It's called openports.co. And what I'm doing here is I'm iterating through ports 80 through 81, and I'm seeing if I can get to those ports egress. So this spits out JSON. It's kind of a standard format, and I'm like, I want to do other things with that. Let's pipe this through JQ and let's check out the status field. I'm getting a bunch of stuff I don't want to see, so I'm like, Control C. All right, let's silence curl. Let's run that again. And let's strip out the quotes. Okay, so what port's open? All right, let's Control C again. Now let's echo the port. There we go. So you see, I didn't have to change anything on the back end, but you make the interface flexible enough to where if someone wants to do a whole bunch of stuff with it on the outside, they can. You know, it's simple. You give it an input, in this case, a port at the very end, and then it comes back with an output. Those are the types of things you kind of have to keep in mind when you're designing software. This one's hard. I'm saying this one's hard because we want to get stuff done, and these things initially always get in your way. And you could probably ask Wes about this, because he's one of the folks that I mentor. His linting was horrible at one point. It's better. But practice like you play. Practice like other people are going to read your code. Use linting, use unit tests. I'm really terrible at this, but I'm really trying to get better. Package your stuff so that it can be deployed. And build in monitoring. So when you make an application, build in monitoring that helps people know if this thing is running healthy or not. These things will help with technical debt and security, by the way, moving forward. Let's see, I got 15 minutes. So, no, I want to leave at least 15 minutes for our Q&A. So, okay, so practice like you play, continued. Think like hackers and attackers, meaning when you're writing your software, think about how something can be abused. And if you don't know how it can be abused, do a Google for it. Say, and I gave you an example, I wrote something in Jinja 2 recently, and I was like, I don't know how to attack this, but I bet Google does. And I was right. And it helped me write more secure code because you do things like search for fuzzing, command injection, SQL injection associated with the types of things that you're going to be writing. And you just make sure that you code so that those things don't happen. And even then, you're not guaranteed to write an application that isn't vulnerable. It's just that you've done your due diligence and you won't be quite so embarrassed when it actually happens. So, and I firmly believe that there's, there's two types of people in the world: those who've been hacked and those who don't know about it. So, I know it's kind of a crappy thing to say, but software is so hard. All right. So let me give you some point of view stuff from working in the industry, the tech industry, for a couple years. Hopefully helpful advice. So the new hotness is the cloud, right? And the cloud is amazing. AWS, Azure, Google Cloud. The things that they're doing for our industry are incredible, and they're making things so much quicker. It reduces the barrier to writing enterprise software dramatically. Before, you had to have like big old honking servers, and you had to provision them correctly, and then there was a huge cost back in because you're like, I'm going to spend $30,000 on the server on a service that I have no idea if it's even going to work. Like, I'm out a whole bunch of money. Whereas with with EC2, you're like, I'm going to spin up this small instance, and then like, oh, wow, this is really successful. Well, I'm going to auto-scale this bad boy and serve millions of requests and make a boatload of money without having to like put a whole bunch of money up front. The flip side of this is you're going to pay out the nose for that convenience. They charge a premium, and they're good at it. So something that people don't realize is that the cloud is other people's computers, and this has been going on for a long time. You guys heard of mainframes? We have one in the picture there. That's all that was, is someone would host a server prompt or like a shell, and then people would do their work, and then they'd log out. So this concept isn't exactly new. Just because something's been done a certain way doesn't mean that's the way you need to do it moving forward, though. So always keep that in mind and try to be flexible with your approach. Technology ages. Some concepts stay the same, but technology is always going to change. If you keep holding on to the same thing, you're probably going to get bit by that from an experience standpoint. So really try to be flexible. So This one's kind of interesting. So how many of you guys work for large companies? Or want to work for large companies, I should say. Okay. What's that? Oh, how about over 1,000 users, computer users? It's a decent sized company. So I think my company, Barracuda, has what, 2,000? 1,800. So, yeah. So most companies, and this is something that you should always keep in mind, companies want to make money. And no matter how altruistic you may feel, that's where a lot of the executives' bottom line is. If you can kind of come from that standpoint, you'll be in a much better place in understanding what some of their decision processes are. And you may not always agree with them, but it's good to be aware of. And a lot of times we look at management or executives and we think this, like, why are they making these decisions? They don't make any sense. And usually from my standpoint, it's always been resources. Like, we need more people. Like, we're not able to catch up. We're not able to do more things. And they have their reasons for that. And vice versa. We complain to them about resources and they're like, we need you to stop whining and do your job and do more with less. That's the big quote, right? So a takeaway from that is that a lot of times I see, especially with people that are entering the industry, is they get frustrated with the way that companies are run. And by the way, companies like Google and Facebook, they're not immune to this. They have the same problems that we do. But if you understand it, that like, why don't they take security more seriously, or why don't they do that? Well, it's because it costs money. It doesn't make them money. And the sooner you realize that that is an immutable fact of life with corporate America, you either accept it or, I don't know, figure something else out. But it's kind of important aside. So technology is easy, people are hard. Emotional intelligence is hard to come by, and you'll find that not everybody has emotional intelligence. They're not able to really try to put themselves into other people's shoes when they're going through their day-to-day, so it can be, sometimes the experience can be difficult. The higher you go in tech, generally the more pressure you have. So when you work for a company like, you work for a mom and pop place. I used to work for a company called Howell Electric. And I was their sysadmin, and it was a chill job, but it drove me nuts, because I didn't have enough to do. But I really didn't have too much conflict. It was kind of, cool. And then I worked for the city, and it ratcheted up, and now I work for Barracuda, ratcheted up some more. And I have a friend that works for AWS in their web services department, and that guy's a stress ball. Just be aware, like, everybody wants to work for Google, but there's a lot of pressure involved with that, to go with that pay. So, and people under stress tend to be jerks. That's kind of something you can't really get away from. Call people out if they're being jerks. Try to do it as nicely as possible, but be like, you're kind of being a jerk. And you'd be surprised, a lot of times people will react by like, oh, I didn't realize that, and they'll become your best friend. Like, I know it's just kind of, it's one of those things. Like, I've had a couple of experiences like that where I call someone out and I don't know. A lot of times they don't know they're doing it, and two, sometimes they respect you a whole lot for it too. Just being straight with people, because we don't have enough of that either. So yeah, just some basics. Be patient. Exercise the golden rule. Treat people the way you want to be treated. And this one's huge for me, is first seek to understand and then to be understood. You'll get a lot of mileage out of life if you do that. All right. So this one's obviously very important. You're important, and thanks for showing up here. I think this is like, you showing up to something like this means that you want to better yourself, be a better developer, be a better person, be a better employee, learn new things, and I think that's awesome. So kudos. Pat yourself on the back. I think it's important. So about treating yourself kindly, raises, something that people don't talk about a lot. But if you don't ask for raises, a lot of times they won't give you one. So if you think you're doing good and you want more money, ask them. Because most of the time they're not going to volunteer, i.e. cost. They want money, right? And you cost the most money out of anything that you're their biggest cost center. People are their biggest cost center. So it's really important that you try to take care of yourself and ask for more money if you think you deserve it. What's the worst that can happen? They can say no. Yeah. Treat your coworkers and your company kindly. Now this one's kind of interesting because treating your coworkers and company kindly means that you're not going to leave them in the lurch if you decide to split. So make sure that you document your stuff. Being the only person in the company that knows how to do something is not job security, and you suck if you do that, like with that intent. Most people do it and they don't even realize they're doing it, but what's that? Yep, hit by a bus. You know, and we won't always have like the 3 envelopes. Sysadmin is leaving, and they say there's 3 envelopes there for you. And the first envelope is blame it on the contractor. Second envelope is blame it on me. Third envelope is write 3 envelopes. So I probably could have told that better, but whatever. So ego is a big one. People in our industry are wicked smart, and don't always judge a book by its cover. I think that's not gonna serve you well at all, ever, pretty much. There's people out there that are smarter than you, and it's the reason why I go to conferences like Black Hat is because, or DEF CON. You got Black Hat stuck in my head.
I know.
You know, you go to these conferences and you just meet amazing people, wicked smart people, and it's so inspiring, and it really does. It's like every year I get a little bit of humble pie by meeting, you know, some of the people that I really look up to. You'll also be served well by trying to leave your ego behind, by realizing that other people may have better ideas than you. They may have better ways of doing things than you. That's okay. Try to keep an open mind, and again, that comes with the whole like be patient thing. And be patient with yourself and realize that you're not always going to be right. And this one's hard for a lot of people, and I would definitely bundle myself up with that one. So this one's near and dear to my heart. Mentoring. Being a mentor and being a mentee. Like I mentioned, you know, Wes is one of the folks that I work closely with, and I consider him one of my mentees. I had a mentor, the guy that I told you about that works for AWS Web Services, and he really got me started. And I think that this is important to me because it short circuits a whole lot of crap from the standpoint of I don't know what I don't know when I'm first starting out. So how do I Google for this problem? What terms do I use? You don't know. You can go to a mentor a lot of times and be like, hey, you know, Bob, I want to do this thing and it does this and this. And Bob can almost immediately go, oh, you're talking about like shifting arrays, or like, you know, you're talking about an iterator function or like whatever. And like, go Google this. Cuts out like probably 8 hours of like toil on your part, and short circuits that whole process of like, you know, kind of giving you a speed bump or a speed boost when you need it. And it's an incredibly rewarding relationship, and you don't always hold on to them, you know, but they're really valuable. And be a mentor as well. So if you know more about, or if you think you know something well, and you see people that are just starting out, be a mentor. It's a great relationship, and you learn things. You learn new things by being a mentor as well, because that you get asked questions all the time that you're just like, I don't know. I can't answer that. Or sometimes they show you stuff on the command line and I'm just like, you showed me something new. That's awesome. You know, so yeah, it's good times. So we're running short on time. I'm going to try to get through these kind of quickly. So this is at the heart of like what we aspire to be, the Google SRE model. They had some very smart people come up with this, and obviously Google runs at scale. They probably have more traffic than any other site in the world. As a matter of fact, I'm pretty sure that's a true statement. But some basics of the SRE model. So at the bottom there, you see like this is basically the most important things on the bottom, the foundations up. And one of the foundations is monitoring. So having situational awareness of your application, period. 2 is when there is an incident, you respond to it and you remediate it. And then you have a blameless postmortem. Blameless means that it's not going to be a bunch of people getting in a room and going like, you know, Jerry screwed up and it's not my fault. Nobody cares about that. Identify the problem and figure out how you can fix it and prevent it from happening in the future, and then move on. Testing your application stack, capacity and planning, development, and then product services. So product services is like if you were looking at the Facebook thing, that's what, when you hit that website, that's what that is, the top of that pyramid. So there's a whole lot more that's going on below the surface than you can see. What's that? Yeah, yeah. So when I was telling you about ops and the landscape changing, this is what I was talking about. So the new paradigm is that you hear DevOps or DevSecOps. Traditionally, operations and developers, or operations and IT, sysadmin, those kind of be used interchangeably. But it used to be the sysadmin guys that would run the IT department, and then you'd have the developers, and the developers would write the software and they'd throw it over the wall. And the admins would go like, what is this crap? And then they would throw it on the server, and then they would run it, and that was the end of the story, right? Oh, and the people that were responsible for running, or the people that were responsible for the alerting and the monitoring and the paging, those were the IT guys. They didn't write the software. So if the developers broke the stack, the IT guys would be the ones that have to fix it, and they have no idea what the hell's going on in the software. How much sense does that make? It doesn't. So now the paradigm is shifted to where the developers and the sysadmins, the people running the system, all this stuff is starting to congeal. Like there's less definition between those two groups. Don't get me wrong, there still is, and there probably will be. System experts, people that know the underlying hardware and the systems, regardless if it's running on a VM or not, they need to know that particular part. A lot of developers, they don't care. I don't care how many open file handles you have. I don't care what your file system limits are. I just want things to work. So, but the second part of this is you have this, like if you have a Venn diagram, if you have a Venn diagram, that bubble in the middle is starting to get much bigger where the operators know how to touch the code pieces that matter, and the developers know how to touch the infrastructure pieces that matter to them. It's moving very quickly, and it's going to continue to move quickly. Also, like kind of a side note, don't try to keep up with everything. Things are going to change so fast, you really want to focus on the things that you know how to do or your areas of responsibility, and let everything else kind of like go by. You're going to drive yourself nuts if you try to be an expert at all this stuff. Like I was saying, the barrier for entry is significantly removed because they have deployment strategies like Terraform. Amazon offers services, so you don't even have to run your servers anymore. If I want a database, I spin up an RDS instance, and then I'm done. Like I don't have to worry about the security or the underlying security of it. I don't have to worry about all these things that were costly from an administrative standpoint. And it makes things much easier to deploy and to scale. Let's see. So I kind of already covered this. This is just more rehashing of devs and SREs working hand in hand. Another part of this, and this is probably the hardest thing to make happen, is Google has a thing where 50% of my time, you're going to do firefighting regardless, but 50% of my time is going to be ad hoc work, and 50% is going to be shoring up technical debt, making sure that things are secure, and like basically making sure that our system is running as tight as it can be. I would say in a lot of organizations, these numbers are greatly skewed, ranging anywhere from 10 to 90% to, like this would be perfect, but I would say that most organizations run 80 to 90 ad hoc interrupt work. A lot of toil, a lot of grind, and it's hard to achieve this, and management has to buy in hook, line, and sinker, and that's hard to do. Because they see a lot of these things as kind of a waste. The other part is that developers and engineers share responsibility for application and reliability and monitoring, meaning that now engineers actually get paged for issues. So when they break the code, they get paged, and you share that responsibility from an infrastructure standpoint. Postmortems are huge, and the key principles there are like make sure that they're blameless, don't blame people, come up with remediation tasks, and fix your stuff, and also be careful, be aware, this is kind of a side note, that sometimes you can break things worse by fixing it, so you need to keep that in mind. There's circumstances where remediation tasks just lead to other incidents, so you need to be kind of hyper aware of the types of changes that you're making. Like sometimes you want to fix a patch a hole and you end up making the hole worse. Something to keep in mind. So this last part. So say you go through all this and you're working at a company for a couple years and you're unhappy. You want to do all these things, but it's not happening. What are your options? So as far as I can see, there are three. You can change the company from within, meaning maybe you work a little harder to put in services that you think need to be done that they may not necessarily want, and this means you working overtime and stuff like that. And I'm not advocating for throwing off your work-life balance at all. So this is only something if you feel really strongly about it, put in some extra work to make things happen. I've done it personally because I find it rewarding. Like I said, I love writing software. So when I spend a weekend writing a bot or writing a Python program, I do it because like that's me like doing art. It would almost be an equivalent of sculpting clay or, painting something. It's really cathartic and relaxing for me. And I'm also helping the company. The other part is change your viewpoint. Sometimes you can dramatically help yourself by changing the way you look at things. And accepting some things, not being quite the way you want them, but, that's life. And the third one is change your view, so leave. We have options. If a company's not doing something or they're not up to snuff as far as you're concerned and you don't see any of the other options working, then split. There's nothing wrong with that. So big thanks to Root Access, Derek and Andrew. They're not here, obviously. They have great meetings. I'd recommend going there and checking it out. Every Wednesday, they host a Linux meetup that I kind of hang around at. If you guys are interested in learning more about Linux, it's one of the few things I would probably consider myself an expert at, and I use that loosely. My vice president, a little story about the Linux thing. I told my vice president I think I'm a Linux expert, and he says, "Oh, you program the kernel?" And I was like, "Okay, I know a lot about Linux." So he made me eat a little humble pie. when I said that. All right, so Q&A. I'm sorry that I actually got through that a lot. I wasn't quite as quick on those slides as I would have expected. I thought I was going to run under. So I'm sorry that I didn't give you enough time for Q&A. Does anybody have any questions?
Yeah, so you said when you were, it's a good idea to write software with security in mind, so always kind of design around that. But I found myself whenever I try to write software for the first time with optimization in mind, I do it far more slowly and it ends up turning out like worse than if I just like did it to run and then went back over to revise for optimization.
That's a really good point. See, over-optimization is a pitfall that happens all the time. With those short iteration cycles that I was talking about, and this kind of, you fall into that trap, right? You're like, I want to write this so that it's like the best possible thing.
Yeah.
Sometimes writing software so that it works, and I tell Wes this all the time, he shows me something and I'm like, does it work? He's like, yeah, and I'm like, this is awesome, you know? Preemptively over-optimizing things is a detriment a lot of times, and you'll find it's a bit of a disservice to yourself. Like, get it to work, get a proof of concept going, and if that's something that if it works, then you can iterate on it and make it better. You can make it more efficient. You know, if it works at 10,000 requests a minute, it may not work at 1,000,000. Cross that bridge when you get to it. You know, don't optimize it for 1,000,000 if you don't think it's even going to survive the first iteration of development.
Yeah, and do you also find that applies to the security concept, like coding with security in, like rather just make it work and then make it unbreakable?
Well, you're never going to make something unbreakable.
Oh, well, I mean,
Sorry, that's pedant me going, but so do due diligence. Don't write anything that's obviously insecure. And there's also, that's why that testing cycle was in place. Yeah, you want to?
I was going to say, it also comes with time that you'll realize, oh, this is insecure for X, Y, Z reason.
Okay.
But you'll gain those knowledges, and you'll automatically start doing those as a preset instead of saying, oh, I'm going to insecure. You'll come for everything.
And-
Depends where it's going to live.
Yeah.
If it's in like dev and it's internal, it can be kind of insecure. If it's bridging your internal gap between like internal and like intranet, please don't.
And hopefully that stuff will get caught in testing too. You know, if it's going to be customer-facing production code exposed to the internet, touching sensitive data, the stuff needs to be vetted by people that know how to fuzz and break things. So yeah, good question.
Basically hire someone who's more creative.
It's absolutely valid, because I'm a big fan of hiring people that know more than I do about a whole bunch of stuff, and I do that all the time.
I always read on the internet that when you're working on a project that has like something that needs to be secured, it's always good to have someone to have someone break it so they can tell you how to fix it
That's absolutely right.
and how they broke it.
Yep. It's valuable. That expertise is expensive, and it's valuable. So if you can hire it out, I'd say absolutely. You get into a lot of trouble trying to do all that stuff yourself. It's like my dentist. He says when I go to my domain, it doesn't resolve, and I'm like, is your Windows domain the same as your web domain? Yeah. It's like, you need to hire people that actually know what they're doing to put your stuff together. You know, like, hire experts. It works. You know, and they know what they're doing, and you're going to be happier as a result. We have 5 minutes left. Anybody have any questions? Well, folks, thank you very much for sitting through this, and hit me up after if you have any more questions or you want to chat. So, thank you.